Question number 6 from section 4.1, inverse function. It has several parts. We're asked for the function f of x, which is equal to 5x minus 6, determine whether f of x is 1 to 1. Well, we know a function is 1 to 1 if it passes a horizontal line test. So you can make a quick sketch of this function. Hopefully you recognize this as a linear function in the form of y equals mx plus b. And the slope of this line is 5, and the y-intercept is negative 6. So you can make a quick sketch if you graph 1, 2, 3, 4, 5, 6. That's your y-intercept, and the slope is up 5 over 1, up 5 over 1, and so on. You get this linear function. You can use a graphing calculator also to confirm that, or even make a table of values. So is this function a one-to-one function? Well, if you draw any horizontal line, it's only going to go through one point at a time. So it passes the horizontal line test. I'm going to use HLT for the abbreviation. Passes the horizontal line test, so we could say yes, f of x is 1 to 1. The second part is to find the inverse of the function. Once you know that a function is 1 to 1, you can go through the steps to find the inverse. Now remember those 4 steps for finding the inverse. The first step is to replace the f of x with a y. Using this equation here, I'm going to replace f of x with y equals 5x minus 6. And then the second step would be to interchange just the x's and the y's, keep everything else the same. So where you see a y, you're going to put an x, and where you see an x, you're going to put a y. Now we're going to solve this equation for y. I'm going to add 6 to both sides, and I get x plus 6 equals 5y. And then finally I'm going to divide both sides by 5 to get y by itself. Let me write that answer up here. I get y by itself equals x plus 6, that entire quantity over 5, or you can break it up into 2 fractions here. So and the last step is to replace y with the symbol for the inverse function. F, the little negative 1, f inverse of x, is equal to, we can write this as x over 5 plus 6 over 5. That's our inverse function. So x divided by 5 plus 6 divided by 5. Yes, and check your answer. Now we want to find the correct domain. The domain for our inverse function, this is also a linear function, and you can sketch this by using the slope and y-intercept. And you can also sketch this by reversing the order of any points that are on your function and the inverse. To determine the domain and range, you can recognize the inverse as a linear function. The inverse, f inverse of x, is x over 5 plus 6 over 5. This is also in the form of mx plus b, like a linear equation. And the slope is 1/5 and the b is 6 over 5. If you do just a rough sketch, the y-intercept is 6 over 5, which is about 1.2. And then from there you're going to go up 1 over 5, and you're going to draw the linear equation that way. If you think about the domain, how far to the left and how far to the right does this graph go? There's no restrictions on the domain. So the domain is from negative infinity to infinity. And whenever you have that infinity, you're going to use parentheses. To find the range, you want to look at the y values, how low and how high the graph goes. This graph is going to continue to go down the page on the left and up the page on the right. So the range is also from negative infinity to infinity. Again, using parentheses whenever you have an infinity sign. The last part of this is to sketch the graphs of the function and its inverse. I did do a little quick sketch here, but I'm going to show you how you can take a couple points on the original function and transpose those to get functions on the inverse. For example, this is kind of a quick way. Just make a table of values for x and f of x. In other words, if I put 0 into the function for f of x, 5 times 0 minus 6 is a negative 6. That's a point on the graph of the original function. Just do one more point here. When x is equal to 1, I plug in 1. 5 times 1 is 5. 5 minus 6 is negative 1. I'll just do one more point here. And we plug in 2. 5 times 2 is 10, and 10 minus 6 is 4. All three of these are points on the original function. The neat thing about inverses is that you can, once you have a graph of the original function, you can find the graph of the inverse simply by interchanging the x's and the y's. So I'm going to plot the point 0, negative 6, 1, negative 1, and 2, 4. Connect those with a line, and those are, it looks like they're using a blue line for the original function. So this is your f of x. Now to find the points of the graph that are on the inverse, x and f of x, we're going to, with a little negative 1, that's the inverse, using this equation here for inverse. What an easy way would be to interchange these x's and y's. For example, when x is negative 6, if you plug negative 6 into the inverse function and simplify it, you're going to get 0 out. And that corresponds to this point right here, 0, negative 6, ends up being the reversed order on the inverse. Also, if you plug in negative 1, negative 1 over 5 plus 6 over 5, it's going to give you positive 1. And if you plug in 4, 4 over 5 plus 6 over 5, you're going to get out 2. And these are all just reverse the order of the x's and y's. You can plot those. 1, 2, 3, 4, 5, 6, negative 6, 0, negative 1, 1, and 1, 2, 3, 4, up 2. I'm going to use a dotted line to show the graph of the inverse function. So you have the blue line is our original function, the pink line is the inverse function. And there's always this correspondence that the points on the original function, for example, this point 2 comma 4, if you reverse the order, you're going to get a point 4 comma 2 that's on the inverse function, f inverse of x. So out of the choices that we have here, it does appear that choice A, and yeah, it looks like choice A is the best answer for graphing both the function and its inverse. Okay, let's go on to number 7. The function f of x, which is equal to 9x plus 2, is 1 to 1. So since it's 1 to 1, we can find the inverse, and then we can state the domain and range and graph it on the same set of axes. This is a lot like question number 6. So the way we find the inverse, you can refer to the 4-step process that I've listed on my math lab. And you're going to take the function and you're going to take that function, replace f of x with y, and you get y equals 9x plus 2. You're going to interchange the x's and the y's. So wherever you see a y, you're going to put an x, and wherever you see an x, you're going to put a y. Everything else remains the same. The third step would be to solve for y. I'm going to subtract 2 from both sides of the equation, and I get x minus 2 equals 9y. And then finally I'm going to divide both sides by 9. to get y by itself, and we get x minus 2 over 9 is equal to y, and that is the same thing as y equals, we can divide both of those by 9, x over 9 minus 2 over 9. And the last step is to replace that y with the symbol for the inverse, which is f negative 1 of x. It's x over 9 minus 2 over 9. Let's check our answer for that one. And then we're going to give the domain and the range. Now the domain, if you recognize, this is a linear function as well. It's in the form of y equals mx plus b. So it's a linear function. It's going to look something like this. The domain and range is going to be from negative infinity to infinity. There are no restrictions on the domain and range. So for both of these, we say the domain is from negative infinity to positive infinity, and that's the same thing as saying all real numbers. All real numbers in the domain and the range. Now the domain and range for the original function ends up being the same, the reverse domain and range for the inverse function. So I went ahead of myself and looked at the inverse function, but the same rules apply for the original function. The domain and range for this linear function is all real numbers. And now the last step in this question is to graph them all on the same axes. We're going to graph f of x in blue, and we'll use pink for inverse of x, and then also graphing the line y equals x. Okay, to sketch these, I'm going to, you can plot a couple points on the original function and use that to graph, and then the inverse is simply reversing the order of x's and y's. So if you make a table for x and f of x, I'm just going to do maybe 2 points here. When x is 0, in the original function you plug in 0, 9 times 0 plus 2 is 2, and let's say you plug in 1, 9 times 1 plus 2 is 11. So by graphing those 2 points, 0, 2, and 1, 11, 7, 8, 9, 10, 11, oh, going off the page here, using a blue line, oops, using a blue line to connect that point, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, way up there. That's your graph of your original function, and then the graph of the inverse is going to be reversing the order. Oops. So the graph of the inverse is going to be reversing the order of those. 0, 2 is a point on the original function. That means 2, 0 is a point on the inverse. 1, 11 is a point on the function, so 11, 0 is a point on the inverse. And you can plot those 2 points. Oh, I'm sorry, 11, 1. 1, 2, 3. Alright, so I'm going to connect those with this line to denote the inverse. So this is your function f, and this is the f inverse. And then we also want to graph the line y equals x. Now the line y equals x is the horizontal line that goes right through the origin. I'm sorry, the diagonal line that goes right through the origin. And the line y equals x looks like that. So for all of these looks like from looks like possibly this one here. Yes, it looks like my original function, the inverse, and then the diagonal line. Okay, let's double check. I may need to zoom into some of these. Oops. Sorry about that. I looked at choice C, which looks correct, but then when I went to check my answer, I actually I selected D. Sorry about that. All right, so for the last two ones, you were finding the inverse, looking at the domain and range, and graphing them both on the axis. The shortcut for graphing is if you know a couple points on the function, simply reverse the order to find the points on the inverse.